Welcome to Calc Chats number 2. Today we're going to talk about the power rule and other basic derivatives. So just to review, what is the derivative? So last time we talked about how for a function, for example, say a parabola, we wouldn't be able to find the slope of the line at the point x using our typical slope formula. However, we can use the tangent line to find the slope at that point of x. So we usually say that the derivative is also the same thing as saying the slope of the tangent line. So it is the slope of the line that touches the graph at one exact point. And remember, we can denote this by using y prime, f prime of x, dx of f of x, or dy dx. Today we're mostly going to be seeing f prime of x. So we're going to start with talking about the derivative of a constant function. So given the function f of x equals c, its derivative will always be 0. So if I'm looking at this function down here below, f of x equals 5, the derivative has to be 0 because 5 is just a constant. And if I look at the graph, f of x equals 5, 1, 2, 3, 4, 5, it's just a horizontal line. And so it makes sense because its slope is 0 anyway. Now we're going on to the power rule. And so the power rule we use mostly for kind of polynomial-looking functions. So given the function f of x equals xn, the derivative, what I do is I take the n down and I put it in front of the x, and then I take for the power n minus 1. So when we're dealing with positive exponents, so the function f of x equals x to the 5th power. So I'm going to use the power rule because I see it has a positive integer power. I'm going to bring the 5 down in front of the x. So this now looks like 5x. And then I'm going to take 5 minus 1 because remember, I deplete the power by 1, so I subtract 1. Sorry, that is f of prime. So f prime is equal to 5x to the 4th. This is our derivative for the function x to the 5th across all of our x values. So now when we're looking at the negative case, and what I mean by this is if I'm looking at the function f of x equals 1 over x to the 4th, looks like a fraction. The first thing I want to do is I want to rewrite this. So when I bring up an exponent from the denominator to the numerator, remember I make it negative. So this is the same thing as x to the negative 4th. I'm going to follow the same exact rule with the power rule. So f prime, I'm going to bring down the negative 4. So negative 4x, and then to the negative 4, I'm going to still subtract 1. So it's still the same rule, but this time with a negative number. So this time I get negative 4 to the x minus 5. And so that is our derivative of 1 over 4. So you always want to do this conversion first. It will make your life 10 times easier. Now when we're dealing with a constant multiple rule, so if I have any function g of x, so this could be x squared, this could be 1 over x to the 5th, anything that we've covered so far, if I have it times a constant, all I need to do is take the derivative of that function and kind of tack on the c right before it like it was before. So if this is confusing, we're going to look at the example. So f of x equals 7x squared. So x squared, that's my g of x. 7 is my constant. So when I take the derivative of 7x squared, I'm going to keep the 7, and then I'm going to take the derivative of x squared. So again, I'm going to bring down that 2. So 7 times 2 times x to the 2 minus 1. So this derivative looks like 7 times 2 is 14 times x to the first power, which is just x. So all I'm going to do is multiply the derivative of my function x squared times 7. Now we're getting on to trigonometric derivatives. So these are kind of where it may get a little more complicated. So there's no real rule for trigonometric derivatives. It's just something that we are going to have to memorize. So the derivative of sine x will always be cosine x. The derivative of cosine x always is going to be negative sine x. And so we can kind of see that these two flip-flop a little bit. So sine, the derivative of sine is cosine, the derivative of cosine is negative sine. So they flip-flop, and we're going to see that across the board. So moving on to the derivative of tangent, the derivative of tangent of x is secant squared x. And the derivative of cotangent is negative cosecant squared x. So again, that negative. When we're looking at the derivative of secant x, our derivative is secant x tan x. So secant of x times the tangent of x. And that's a c, not a parentheses. Ooh. Secant x tan x. And then the derivative of cosecant x is going to be negative cosecant x cotangent of x. So these are all kind of similar. If we can remember generally sine, cosine, tangent, and secant, we can usually be able to get to them all. So these are ones that we're going to have memorized. So this is just a basic example. Find the derivative of g of x of the function g of x equals tangent of x. So this is an example where I just look back in my notes and see, okay, the derivative of tangent of x, secant squared x. So g prime of x just is secant squared x. And it's as simple as that. So now we're going to move on to kind of sums and differences of functions. So when I take the derivative of any sum or difference of functions, I can separate it into separate parts. So down below here, I have this super long function full of multiple different parts. It looks nasty, but we're going to dissect it really fast. So first, I'm just going to kind of rewrite this function because I have some fractions in here. So 6x cubed minus 7 cosine x plus, this is 1 over 2 x cubed. So what I'm going to do is I'm going to write this as 1/2 x to the negative 3. The reason I'm not writing this as 2x to the negative 3 is because this 2 isn't being cubed, so this wouldn't be the right way to write it. So I kind of want to split it up as to 1/2 times 1 over x cubed, and that transforms into 1/2 x to the negative 3 plus 10x minus 117. So I have a lot of different functions going on here, but I can split them up really nicely. So let's first focus on 6x cubed. So when I'm looking at my derivative, let's write f prime of x equals the derivative of 6x cubed. Remember, bring down the 3. 3 times 6, x to the 3 minus 1. It's as simple as that. Negative 7 cosine x. When I have that constant in front of it, it just stays. So negative 7 times negative sine of x plus this 1/2 x to the negative 3, bring down the negative 3. I have 1/2 times negative 3, x to the negative 3 minus 1, plus 10x. We have a constant, so I'm just going to leave it, plus 10. And then the derivative of x is just 1, so 10 times 1. And then minus the derivative of 117 is just 0. So when I finally simplify this function, it looks like 18x squared. I have this double negative plus 7 sine x plus negative 3 over 2 x to the negative 4 plus 10. And that is going to be my final answer. So when I have things or functions being added together or subtracted, I can just split them up in order to find their derivatives. So this has been the lesson on the power rule and other basic derivatives. Please come to class with any questions that you may have, and we'll work hard on this on our next class. Thank you for watching. Oh, and be sure to like and subscribe to my YouTube channel so that you can get updates on your video every time.